Hey everybody. Before you watch this video, you should have completed from this exploration numbers 1 through 6. We'll go over that briefly and then we'll work through 7 through 10 together. In this exploration, we have a couple objectives, mainly to use matrices to perform transformations, but a sort of short-term one is we have not even used them to describe figures yet. So let's make sure in a number 1 that you are able to interpret correctly what it is we're looking at. So in matrix M, we've got a 2 by 3. There are 3 points that they're describing, and they're listing the x and the y coordinate of those points. So let's just make sure, based on kind of what you're seeing on that triangle here, this first column gives you point 1, where, well, this is not very helpful because they're both the same, but the first row is the x and the second row is the y. Maybe point 2 is a little bit more helpful. We've got a point at 4, 2. So I want to make sure first that you know how to, here's a matrix. Can I plot points from that matrix? Okay, then number 2, you are applying a transformation matrix. We're going to pay attention to the order. If that's a 2 by 3 and this is a 2 by 2, they're going to have to go this way first so that you have a 2 by 2 times a 2 by 3. If we switch those around, which is what the next question was asking, we would have a little dimension mismatch. What happens is, let me uncover my result here. You get a matrix that looks like this. All the numbers are just twice as big. That really is doing the same thing as scalar multiplication. We are going to want to write it like this so that we can do more than just dilations at once. We're going to be able to write matrices that do all the transformations all in one shot. Okay, so it feels like scalar multiplication, but we're really going to use regular matrix multiplication to do that. Okay, just one more note here. Oh, I should mention, once you plot this, I'm going to skip this part, what we're looking at is a triangle where you could say it's twice as big. Let's be specific. We are dilating. We're making everything 2 times further away from the origin. So like if I looked at this distance, for example, and then this distance, it's doubling, right? So those points are all 2 times further away with respect to the origin. And then quick vocab here, because we're going to use these throughout the rest of the chapter. Image and pre-image. Pre-image is what you start with. So that triangle that they're describing with matrix M, that's our pre-image. The new one that you get after you transform it is called the image. So just watch out for those words, though. They'll show up every once in a while. Okay, on to number 7. Matrix B is another transformation matrix. Looks very different than matrix A. Let's just apply the transformation and then see if we can tell what this is doing. Maybe you have a guess just based on how this looks. Let's go ahead and enter in. Let's put these in our calculator. You might already have one in there. I'm going to just put these in to start. So I'm going to might as well put B in B. I notice that's 90 degrees. So if you are not in degree mode, or maybe you want to do a quick test anyways, go ahead and switch to degree mode. And I'm going to edit matrix B so that it has this 2 by 2. Whoops, that's not B. Let me try that again. Matrix B. I'm going to type just as I'm seeing here, cosine of 90. Uh-oh, that's 0. Is that a problem? Cosine of 180. -1. Can we just pause and think about those for a second? It's just simplifying those. Cosine of 90, think about the graph of cosine, right? You've got your cosine curve. Cosine of 90 is 0. Cosine of 180 is -1. So these are actually going to clean up nicely. They won't always be such nice clean numbers, so we're just going to type them in using the degree measure that they're giving us. All right, so go ahead and finish typing that in. There's my 2 by 2. It should look like that when it's simplified, 0, -1, 1, 0. If you're not seeing those numbers, you're probably not in the right mode. Okay, and then I need to also put in, if you didn't already do this, I need to put in my original pre-image matrix. I think I'm going to put mine in A. If you already have something in A and you want to pick another one, fine, just keep track of where it is. So I'm going to put in my 2 by 3. And then I want the product in this order, transformation matrix first times the preimage. So for me, that's B times A. If yours are not stored in those same matrices, then just use whatever you have. Should look like that. Okay, so let's write down that product, and then we're going to plot that and see if we can decipher based on the graph and keeping in mind what B looked like, what kind of transformation we're working with. Okay, so go ahead and plot those points. I have mine already plotted. I'm going to uncover that in a second. As you're doing that, I want you looking at the dotted triangle that was there initially and this new one that you're about to plot. And let's see if we can come to a consensus here. What type of transformation occurred? Is under here? Nope, wrong one. Okay, so here we go. Let me highlight because I've got quite a few triangles on here. This blue dotted one was the original. We already talked about that big one where my number 4 is. I'll skip that one for now. Number 7 is what we should have just gotten, the one I have highlighted there, that red one. Do you know what kind of transformation that is? It's not just translating, it's also, well, it is rotating with respect to the origin. If we were to sort of investigate a little bit further, or maybe you can just tell by kind of eyeballing it here, it is a 90-degree rotation counterclockwise. So let's take a look at number 8. Okay, that matrix rotates the preimage by 90 degrees counterclockwise. Our task is to write a new matrix, we'll call it C, that will still rotate, but by 40 degrees counterclockwise. We're going to try to write a new matrix C that we think will rotate 40 degrees counterclockwise. Do you have some thoughts about that? Now, let's keep reading because they give us some help here. It says, to do this, you should realize that the angle in the second column is 90 degrees more than the angle in the first column. So we could see, okay, that 90, I saw a 90-degree rotation, 180, and we'll talk about why does that happen? Let's kind of just be able to do the transformations first, and then in the next lesson we'll work through what's going on there, why those two measures, why cosine and sine. Let's just worry about can we do them first. So this would equal, you can maybe try it first. Actually, I'm going to write kind of in silence here. You give it a try, and then we'll regroup in a second here. Do ours match? Now, let's try it out. We're going to throw that in the calculator. Just put it in for C. It is going to convert it to decimals. Again, you'll see they're not nice, clean zeros and ones this time because we're using kind of these weird angles, 40 and 130. So let's go ahead and edit matrix C. And we'll put in this 2 by 2. Cosine in the first row, just like the x coordinates were in the first row. I think at this point we're used to like cosine and x always go together. So let's make sure we get those in the right spot. Okay, you want to take a peek as you're typing these in, make sure your decimals match mine. Check to make sure I don't do anything incorrect also. Okay, should look like that, about 0.8 to negative 0.6, 0.6, and again about 0.8. And then we're going to multiply. So let's do, again, always the transformation matrix first. So transformation matrix C times, remember where your pre-image is stored. For me, that should be your the only 2 by 3 that you have in there. C times A. Now you're getting these messy decimals. Let's just round them. There is a setting we can change. Let's try to remember to do that next week. You can change like a float setting so you don't see quite as many decimals. But if you just scroll over right away, you have that arrow option, you should be able to see the rest of the entries. If you want to just peek at my board, I'm going to write down, maybe while I have some space here in number 9, I'm going to just write down what the product C times M is, and I'll just round them so that we can plot them. So our first point is about 0.1, 1.4, 1.8, 4.1, and negative 1.2, 2.9. Okay, so go ahead and plot those. should end up with something that looks like the green highlighted one there. I have a number 9 inside of mine. And it should look like, and we could like take a protractor out and really try to investigate this, but it should look like a 40-degree counterclockwise rotation. So from blue to green, we're only rotating 40 degrees. All of this is with respect to the origin. That's the point which we're rotating about. Okay, last problem here, number 10. We're going to write a matrix that does both things, dilates by a factor of 2. So let's think about what that looked like from problem number 2, and rotates by 240 degrees. Now, you could do them sort of one at a time, but what ends up happening, let's maybe just jump to the short version. We're just going to squish these into one big matrix. Actually, you know what? I do need to show you something here. Just watch my screen here for a second. You don't necessarily need to write this one down. If we did these individually, so we took a dilation by a factor of 2, which would look like that. Notice that's kind of like the identity, but it's 2's instead of 1's. And then we took the matrix that does the rotation. So I'd have cosine of 240 and sine of 240 in my first column. And then remember, you're just adding 90 degrees to that. So I've got cosine of 330 and sine of 330. And forget about even using the pre-image yet. If we just multiplied those together, it would throw a 2 in front of all of these sine and cosine terms. Because remember, that doubled every number. So to do both at once, it is a little bit different than just 2's along the main diagonal. We're actually going to throw 2's everywhere. So 2 times cosine of 240. 2 times sine of 240. And then do the same with 330. This part, I should have mentioned this. You should write this one down with me. Stop for a second there. And then we're going to put that in as matrix. What's free? Do we have D available? Let's edit matrix D. And go ahead and type in that 2 by 2. I'll let you finish the rest of this up on your own. So go ahead and type in that 2 by 2. And then we'll do this matrix times our original pre-image. Let me put the final picture up here, and let's make sure you're getting something that looks similar. Okay, so we should have, let me highlight 2 things here. Here's the product. I can leave this on the screen for you. There's the product that we're looking for. And then this triangle, which remember, what did we want it to do? We wanted to make it twice as big and rotate 240 degrees around the origin. Let's make sure that that's your result. Okay. When you're done with this, you should, I'll flip back a screen here in a second, hop on Schoology and look in the class notes folder for just some summary notes that generalize. If you're trying to rotate, this is what your matrix should look like. If you're trying to dilate, if you're trying to do both, here's what it should look like. So throw that in your notebook so you have it for reference, because then you're going to do just some odd problems from the book over the weekend, numbers 1 through 11 odd. This is a submit to Schoology, so make sure you get those in. Okay, so I'll flip back to this last kind of answer screen here. Feel free to leave it on that screen if you want. You should email me if you have any questions. I'll see you guys Monday.